Hello, good morning everyone. Myself Mallikarjun Huzrati, chemistry lecturer in BVVS Arts, Commerce and Science, Independent PU College, Vidyagiri, Bhagalkot. In this video, I am going to explain one of the important chapter, that is organic chemistry, some basic principles and techniques, which is very useful for your CET, NEET as well as JEE examination. Students, first we will see some synopsis points which are related to the organic chemistry chapter. After that, we will see some multiple choice questions with answers. Come to the point of basics of organic chemistry now. What are the important concepts which are observed in previous year question papers are present here? Focus on these points. First one, introduction of organic chemistry, definition, hydrocarbon and its derivatives, structural formulas, etc. Next, nomenclature of organic compounds, tetravalency of carbon and importance of carbon, hybridization, etc. And also isomers and stereochemistry, definition, types and classification. Chiral molecules, introduction, stereoisomers, conformational isomers and mesocompounds, etc. And also observe the concept which is related to relative and absolute configuration, structural effects means electronic effects, in that delocalization of electrons, hyperconjugation, inductive effect, steric effect as well as angle strain. Students, now come to the point of introduction of organic chemistry. Students, we know one of the easiest definition of organic chemistry is organic chemistry is the branch of chemistry which deals with the study of carbon and carbon containing compounds. And this organic chemistry is also defined as the study of organic compounds. Sometimes the organic chemistry is also defined as the study of hydrocarbons and its derivatives. Just recall some important introduction points which are already you studied, like which one is the first synthesized organic compound? The answer is urea. Remember students, urea is the first synthesized organic compound by Friedrich Euler, one of the famous scientists. Friedrich Euler proposed the urea. And next one, acetic acid, is given by another famous scientist, Kolbe. Next, methane is one of the organic compound given by another famous scientist, Berthelot. Students, and also you studied the tetravalency of carbon. We know carbon has tetravalency. Why carbon has tetravalency? Because in excited state it has 4 valence electrons. Therefore, carbon has tetravalency. Next, another important concept, that is structural representation of organic compounds. In that, we know there are 3 types of structural representation. One is condensed structural representation, open chain structure as well as bond line structure. Students, in the structure, if the carbon atoms are present in open chain, then it is open chain structure. And another important point is condensed structure or condensed formula. Students, to save a space and time in the representation of organic structures, it is common practice to use the condensed formulas in which the bonds are not shown explicitly. Means, in presence of condensed structures, We observe the carbon atom as well as hydrogen atoms, but the bonds are not represent in presence of condensed structure. Just see this example, ethane. Ethane, it is one of the example here, CS3. It contains 2 carbon atoms and 6 hydrogen atoms, but the bond is not represented here. Therefore, it is in the condensed structure. Because this carbon atom contains 3 hydrogen, this carbon atom also contains 3 hydrogen. Similarly, this is a condensed structure of ethene, and this one is the condensed structure of ethine. Here methanol, ethanoic acid, methane nitrile, ethane nitrile. These are some examples for condensed structure. Next, another very important point means 3D representation of organic compounds. Students, here I will show one example. This is the structure of acetone. Is it right? Yes. One important point you remember here, in presence of three-dimensional representation of organic compounds, there are 3 methods. One is wedge and broken line method, ball and stick method, and space filling method. Among these 3, wedge and broken line method is very important. In the structure of bond, in presence of wedge and broken line method, it contains 3 types of bonds. One is normal bond or simple bonds, another one dashed bonds, and another one wedge bond. Among these 3 types of bonds, in the structure, the normal bonds, they indicates they are present on the paper or lying on the plane of the paper. And solid wedge, it indicates it is present above the plane and towards the observer. See here students, this is the solid wedge or wedged bond. It is present above the plane and towards the observer. Next, a dashed bond, it indicates it is present below the plane and away from the observer. As see here, this bond means dashed bond, it is present below the plane and away from the observer. Next, skeletal formula, or also called as bond line structure, or this sometime it also called as line angle formula. Some examples are given here. This is structure of acetone. See here, first one example, acetone. Here only bond, single bond means here CS3 is present, here C and double bond O, and here CS3, CS3CO, CS3, it is the formula of acetone. Similarly, here CS3 is present, here CH2 is present, here only 3 bond means CH is remained here, CHO. Yes, this is structure of propanol. Okay students, next another very important concept, that is classification of organic compounds. Organic compounds constitutes about 90% of all compounds. You remember this point. Depending upon the arrangement of carbon atoms in their structure, organic compounds are broadly categorized into acyclic or open chain compounds, cyclic or closed chain compounds. Students, remember there are means in the classification of organic compounds, mainly there are 2 types. One is acyclic and another one cyclic. Yes, these cyclic or closed chain compounds again classified into 2 types. What are those? Homocyclic and heterocyclic compounds. Those homocyclic compounds are again classified into alicyclic and aromatic compounds. These aromatic compounds are observed in presence of benzenoids and non-benzenoid compounds. Yes. Come to the point of acyclic or open chain compounds. These are also called as aliphatic compounds. What are acyclic compounds? Students, we know the organic compounds which contain open chain of carbon atom are called acyclic compounds. The compounds which contain open chain of carbon atom are called acyclic compounds. All alkanes, alkenes and alkynes are comes under acyclic compounds. One important thing you remember here, those compounds in which first and last carbon atoms are not connected with each other, branched or unbranched chains are possible in presence of aliphatic or open chain compounds. Yes. Next, another one, or see here the given example. This is an example for isobutylene. It contains the carbon with double bond and respective hydrogen atoms. Here open chain of carbon atom is present. Therefore, this is an example for acyclic compounds. Next, cyclic compounds. How you define the cyclic compounds? The organic compounds which contain ring of carbon atom. The compounds which contain the ring of carbon atom. Remember students, in these type of compounds, the first and last carbon atoms are attached with each other. If you take an example, cyclopropane, cyclobutane, these are some examples for cyclic compounds. We know these cyclic compounds are again classified into two types. What are those? Homocyclic and heterocyclic compounds. What are homocyclic compounds? What are homocyclic compounds? We know the organic compounds which contain the ring structure and made with same kind of atoms. The organic compounds which contain the ring structure and made with same kind of atoms are called homocyclic compounds. If you take an example, cyclopropane, cyclobutane, it contains similar groups. These are examples for homocyclic. Homo means same. Next is homocyclic compounds are again classified into two types: alicyclic compounds and aromatic compounds. As what are alicyclic compounds? Remember students, the organic compounds which have ring structure and have aliphatic properties. Alicyclic compounds are the organic compounds which have ring structure and have aliphatic properties are called as alicyclic compounds. And what are aromatic compounds? Aromatic compounds means the compounds which contain at least one benzene ring are called aromatic compounds. Some examples are given here for alicyclic compounds as well as aromatic compounds. If you take an example, cyclopropane, here CH2, CH2, CH2 similar groups are present and it has aliphatic properties. Similarly, cyclobutane, cyclopentane, cyclohexane. And students, aromatic compounds means the compounds which contain at least one benzene ring. But these aromatic compounds are observed in presence of benzenoids and non-benzenoid aromatic compounds. Benzenoid means they contain benzene. Non-benzenoid means they do not contain benzene ring, but they have aromatic properties. See here, benzene, it is the first member of aromatic compound. Toluene, paraxylene, metaxylene, and this one is the aniline. We'll see. Next, another type of compounds, bicyclic and tricyclic compounds. Bicyclic means it contains two cyclic rings. Naphthalene, bicyclic compound, and phenanthracene, tricyclic, anthracene also tricyclic. Some examples are given here. And non-benzenoid aromatic compounds. What are non-benzenoid aromatic compounds? aromatic compounds that contain other highly unsaturated rings in place of the benzene ring. Yes, these are called non-benzenoid aromatic compounds. And heterocyclic compounds. What are heterocyclic compounds? Students, remember, these are the compounds in which one of the carbon atom is replaced by other atoms like nitrogen, sulfur, oxygen, etc. Means hetero means different. When you observe the organic compound, one or more carbon atoms is replaced by the hetero atoms like nitrogen, sulfur, oxygen, etc. Yes, some examples are given here. Yes, when you observe this structure, here carbon atoms is replaced by oxygen atom. Here carbon atom is replaced by sulfur. In presence of pyrrole, carbon atom is replaced by NH. Pyridine, here nitrogen is present. Now another concept, that is IUPAC nomenclature of organic compounds. Students, remember, this is one of the very important for your CET as well as NEET examination, because compulsory 1 or 2 questions present on nomenclature of organic compounds. ಈ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಈ ಚಾಪ್ಟರ್ದೊಳಗೆ ಏನು ಮಾಡ್ಬೇಕು, ನಾವು ಜಾಸ್ತಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಬೇಕು. ಯಾಕಂದರೆ ಪ್ರತಿ ವರ್ಷ 1 ಇಲ್ಲ 2 ಯಾವುದೇ ಎಕ್ಸಾಮ್ ಇರಲಿ, ಅಲ್ಲಿ ನೋಮನ್ಕ್ಲೇಚರ್ ಮೇಲೆ ಕ್ವಶನ್ ಇದ್ದೇ ಇರ್ತದೆ. Yes, first see here, what is IUPAC naming system? Yes, IUPAC, it indicates I means international, U means union of, P means pure, and A means applied chemistry. Yes, international union of pure and applied chemistry is IUPAC system. It's a long form of IUPAC. Students, while observing or writing the name of organic compound, first we know the 3 points. What are those? The root word and prefix and suffix. First one is root word, suffix as well as prefix. What is root word? Students, we know already, it indicates by the number of carbon atoms present in the organic compound. And while writing the name of organic compound, this root word, it binds or it holds the prefix as well as suffix. Means it comes middle of the name. Yes, see here, if the organic compound contain 1 carbon atom, then the root word used is meth. If 2 carbon atoms are present, then eth is used. 3 pro, 4 but, 5 pent, 6 hex, 7 hept, 8 oct. Similarly 9, 10, 11, 12 as oct, non, dec, undec, dodec, etc. You at least remember up to decane. ಈ ರೂಟ್ ವರ್ಡ್ ಎಲ್ಲಿ ಕಂಡು ಬರ್ತದೆ, ಇದು ನಾವು ಹೆಸರನ್ನ ಬರಿಬೇಕಾದ್ರೆ ಮಿಡಲ್ ಅಲ್ಲಿ ಕಂಡು ಬರ್ತದ. ಇದೇನ್ ಮಾಡ್ತದ, ಪ್ರೆಫಿಕ್ಸ್ ವರ್ಡ್ ಅನ್ನ ಮತ್ತು ಸಫಿಕ್ಸ್ ವರ್ಡ್ ಅನ್ನ ಎರಡನ್ನೂ ಏನ್ ಮಾಡ್ತದ, ಕಂಬೈನ್ ಮಾಡ್ತದ. Now let us come to the point of primary suffix. What is suffix? It is the part of the word which comes after the root word and it present at the end of the name. Students, it indicates the nature of carbon atom chain selected. Means primary suffix, it indicates the nature of carbon atom chain selected. Only single bond between carbon atoms, then definitely it is one of the alkane. Yes, if you observe the structure of the compound, if it contains only a single bond, then the primary suffix word is ane. ಈ ಒಂದು ಕಂಪೌಂಡ್ ಅನ್ನ ಸ್ಟ್ರಕ್ಚರ್ ನಾವು ನೋಡಿದಾಗ ಅಲ್ಲಿ ಬರೀ ಎಲ್ಲಾ ಕಡೆನೂ ಸಿಂಗಲ್ ಬಾಂಡ್ ಕಂಡು ಬರಾಕತ್ತಿತ್ತು ಅಂದ್ರೆ ಅದೇನಾಗಿರ್ತದ, ಒಂದು ಅಲ್ಕೇನ್ ಅಂತ ಗೊತ್ತಾಕೈತಿ. ಅಂತ ಸಂದರ್ಭದಾಗ ನಾವು ಹೆಸರನ್ನ ಏನ್ ಅಂತ ಎಂಡ್ ಮಾಡಬೇಕಾಗ್ತದ ಅಂತ ಹೇಳ್ತದ. ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಡಬಲ್ ಬಾಂಡ್ between the carbon atoms, then the name ends with ane, means primary suffix is ane. In presence of triple bond between the carbon atoms, the name ends with ine. Students, another important point, if the parent chain contains 2, 3 or more double bonds or triple bonds, then the prefix words like di, tri, tetra, etc. are used. Remember this point also. But one question, what if both double and triple bonds are present between the carbon atoms? ಈಗ ನಾವು ಹೇಳ್ತಿದ್ವಿ ಏನಂತ, ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ನೋಡಿದಾಗ ಅದರೊಳಗೆ 2 3 ಡಬಲ್ ಬಾಂಡ್ ಕಂಡು ಬರಾಕತ್ತಿದ್ದು ಅಂದ್ರೆ ಡೈ ಟ್ರೈ ಟೆಟ್ರಾ ಹಿಂಗೆ ವರ್ಡ್ ಯೂಸ್ ಮಾಡ್ರಿ ಅಂತ ಹೇಳ್ತದ ರೂಲ್. ಓಕೆ, ಆದರೆ ಈ ಒಂದು ಕಂಪೌಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡಿದಾಗ ಡಬಲ್ ಬಾಂಡ್ ಮತ್ತು ಟ್ರಿಬಲ್ ಬಾಂಡ್ ಎರಡೂ ಒಂದು ಕಡೆ ಕಂಡು ಬಂದಾಗ ಏನು ಮಾಡ್ಬೇಕು ನಾವು? ಸಿ ಹಿಯರ್, ದಿಸ್ ಒನ್ ಇಸ್ ದ ಎಕ್ಸಾಂಪಲ್. Here CH triple bond is present, here carbon atom with CH2, CH2, CH, and here one is double bond. During this time, remember both ene and ine are written, but ene comes before ine. Therefore, the name of this compound is hex 1 ene 5 ine. Means you can start the numbering from this side, 1 2 3 4 5 hex. Why hex? Hex is the root word. It contains 6 carbon atoms. No, 1 2 3 4 5 6. Therefore hex, it is the root word. 1 in first carbon atom contain double bond and fifth carbon atom contain triple bond. Therefore ine is the name. Let us come to the point of secondary suffix. Students, secondary suffix, it is indicated by the presence of functional group. You know this point already. The various functional groups with their corresponding suffix words are discussed here. Yes, secondary suffix ಯಾವುದ್ರ ಮುಖಾಂತರ ಕಂಡು ಬರ್ತದೆ ನಮಗೆ? ಆ ಒಂದು ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ದಲ್ಲಿ ಯಾವ ಕ್ರಿಯಾ ಗುಂಪು ಅದ, ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅದ, ಅದ್ರ ಮೇಲೆ ಏನಾಗ್ತದೆ? ಸೆಕೆಂಡರಿ ಸಫಿಕ್ಸ್ ಕಂಡು ಬರ್ತದೆ. See here, if the compound contains COOH group, means carboxylic acid group, then the name ends with oic acid. Similarly, COOR means ester group is present, then the name ends with OH. Similarly, acyl halides, oil halides, if aldehyde group is present, the name ends with al. Ketone is present. If ketone is present in the organic compound, then the secondary suffix on is used. Similarly, some examples: CONH2 amide. Cn means nitrile, means if the organic compound contains Cn group, then the name ends with nitrile. As we know, CHO means aldehyde group is present, the name ends with al. Alcoholic group means OH group is present, then the name ends with all. Remember these points, these are helpful while writing the name of organic compounds. If you take an example, see here, this is structure of propanol, CS3, CH2, CH2, OH. See here, CS3, CH2, CH2, OH. Is it right? Yes, it contains 1, 2, 3 carbon atoms. Therefore, prop is used. OH group is present here. See here, if OH group is present, the name ends with all. Therefore, the name of this compound is propanol. Here, prop is the root word, ane is the primary suffix, all is the secondary suffix. Yes, first prop, ane, all. Overall, propanol. One important point, since the secondary suffix begins with a vowel O, the E of the ane is removed. Suppose ಏನಾದರೂ secondary suffix ಯಾವುದರಿಂದ begins with O ಇತ್ತಂದ್ರೆ ಅಲ್ಲಿ ಆ ಒಂದು ಅಲ್ಕೇನ್ ಏನಂತ ಏನು ಹೆಸರು ಇರ್ತದಲ್ಲ, ಆ ಏನ್ ಅಲ್ಲಿದ್ರು ಇ ಅನ್ನ ರಿಮೂವ್ ಮಾಡಿ ಅಲ್ಲಿ ನಾವೇನು ಕೊಡ್ತೇವೆ? ಓ ಅನ್ನ ಕೊಡ್ತೇವೆ. Yes, since the secondary suffix begins with a vowel O, the E of the ane is removed. Helping word ಆಗಿ ನಾವು ಅಲ್ಲಿ ತಗೊಳ್ತೇವೆ. Now come to the point of prefix. As the word indicates, it means something which is fixed or attached before or at the beginning. Hence, a prefix is written before the root word. Remember, students, prefix, it is also part of the word which comes before the root word. ಈ ಒಂದು prefix ಅನ್ನು ನಾವು root word ಗಿಂತ ಮೊದಲನೇ ಬರಿತೇವೆ. In presence of prefix, there are two types. One is primary prefix and another one secondary prefix. Yes, students, see here some functional groups are present with the prefix means part of the word which is used while writing the organic compound name. Students, if your organic compound contains COOH group but it comes as a prefix, then the word carboxy is used. Similarly, SO3H means sulfo word is used. Like this, CHO means formyl, CO means keto or oxo, OH hydroxy. Yes, ಏನಪ್ಪ ಇಲ್ಲಿ ನಾವು ತಿಳ್ಕೋಬೇಕಾಗಿದ್ದು ಅಂದರೆ ಈ ಒಂದು ಕಂಪೌಂಡ್ ಅಲ್ಲಿ CHO ಗ್ರೂಪು ಪ್ರೆಫಿಕ್ಸ್ ಆಗಿ ಬರಾಕತ್ತದ ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ನಾನು ಏನಂತ ಹೆಸರು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬೇಕಾಕತ್ತಂತ ಫಾರ್ಮೈಲ್ ಅಂತೇಳಿ. CN ಇತ್ತಂದ್ರೆ ಸೈನೋ. ಯಾವಾಗಿದು ಆ ಸೈನೋ ಅನ್ನೋ ಗ್ರೂಪು ಪ್ರೆಫಿಕ್ಸ್ ಆಗಿ ಬರಾಕತ್ತ ಸಂದರ್ಭದಲ್ಲಿ ಏನಂತ ವರ್ಡ್ ಯೂಸ್ ಮಾಡ್ಬೇಕು ನಾನು? CN ಇದ್ರೆ ಸೈನೋ, CHO ಇದ್ರೆ ಫಾರ್ಮೈಲ್, ಕೀಟೋನ್ ಗ್ರೂಪ್ ಇದ್ರೆ ಕೀಟೋನ್, OH ಗ್ರೂಪ್ ಇದ್ರೆ ಹೈಡ್ರಾಕ್ಸಿ, NH2 ಗ್ರೂಪ್ ಇದ್ರೆ ಅಮೈನೋ. ಈ ತರ ವರ್ಡ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಬೇಕು ಅದು ಪ್ರೆಫಿಕ್ಸ್ ಅಲ್ಲಿ. Yes, students, see here one example. It contains one functional group OH. Is it right? Yes, this is one of the functional group. Therefore, you can start the numbering from here. Here already I given 1, 2, 3, 4 means it contains 4 carbon atoms. But usually numbers start from this carbon atom because it contains the functional group. According to one rule, we will see later. If the organic compound contain one functional group, then you can start the numbering from that side. Therefore, you can start the numbering from this side. 1, 2, 3, 4 means root word is but. Primary suffix, it contains only single bond. Therefore, the name ends with ane because it is an example, ane. Secondary suffix, here OH group is present. Secondary suffix means suffix. If the OH group comes as a suffix, then the name ends with all. Is it right? Yes. And here one substituent group is attached to this carbon atom, that is Cl means chloro. It is one of the prefix. Therefore, first use the prefix word, that is chloro. Why I write 3? Because for 1, 2, 3, third carbon atom contain Cl group. Therefore, 3 chloro butane 1 all, or 3 chloro but 1 all is the IUPAC name of the given compound. Yes, next, secondary prefix. Certain groups in organic chemistry are written as prefix. They are regarded as substituents. These groups along with their prefix are as follows. Some of the another substituent groups, one is fluoro, chloro, bromo, iodo. Usually these are halogens. These are comes in as a secondary prefix. If fluoro group is present, means fluorine is present, we use fluoro. Cl is present, chloro, bromine group is present, bromo, iodo, etc. Some alkane and their alcohols are written here. Here ethane, its alcohol is ethanol. Ethanol formula CS3CH2OH. And here water, H2O. Propane is one of the hydrocarbon and propanol is one of the alcohol. Butane, butanol, etc. Okay, students, now we will see what are the rules for naming the organic compounds. In that first one, longest chain rule. Students, while writing the IUPAC name, first we select the longest carbon chain in the given compound and give the number according to the root word. See here, in presence of longest chain rule, determine the longest continuous chain of carbon atoms. If you take an example, see here. Here I will give you one example. Here CS3, CH2, CH2, CH2. One of the CH is bonded with CS3 and another CS3 here. Yes, here substituent group is nearer. You can start the numbering from this side and select the longest carbon chain. If you start from this carbon atom, this one is the first, second, third, fourth and fifth, and this one is the sixth carbon atom. Yes, students, the base name corresponds to the number of carbon atoms in the longest chain. ಈಗ ಒಂದು ಕಂಪೌಂಡ್ ನ ಹೆಸರು ಬರೆಯುವಂತ ಸಂದರ್ಭದಲ್ಲಿ ನಾವು ಮೊದಲಿಗೆ ಏನು ಮಾಡಬೇಕಂತ ಯಾವ ಕಡೆಯಿಂದ ಮೂವ್ ಆದರೆ ನಮಗೆ ಹೆಚ್ಚು ಕಾರ್ಬನ್ ಸಂಖ್ಯೆ ಸಿಗ್ತದ, ಕಾರ್ಬನ್ಗಳು ಸಿಗ್ತಾವ, ಅಲ್ಲಿ ಆ ಥರ ಏನು ಮಾಡಬೇಕು, ಮೂವ್ ಆಗಬೇಕು, ಅದಕ್ಕೆ ನಂಬರ್ ಕೊಡ್ತಾ ಹೋಗಬೇಕು. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಒನ್, position of the substituent group. Number of carbon atoms in the parent chain as 1, 2, 3, etc. starting from the end, which gives the lower number to the carbon atoms carrying the substituent group. Always the number from the end of the longest chain closest to the first branch. Yes, if you see this example only, then the second rules, it states that if the organic compound contain one substituent group, then give the least or lowest number to this side of the carbon atom. ಈಗ ಇಲ್ಲಿ ನೋಡಿದರೆ ಒಂದು ರೂಲ್ ಹೇಳ್ತದೆ ಏನಂತ, ಈ ಒಂದು ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ನ ನೀವು ನೋಡಿದಾಗ ಯಾವ ಕಡೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಅಟ್ಯಾಚ್ ಆಗ್ಯದ ಆ ಕಡೆ ಇರ್ತಕ್ಕಂಥ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಂದ ನಾವು ನಂಬರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು ಅಂತೇಳಿ. ಎಸ್, if you observe this example, here this carbon atom contain one X means one substituent group. Is it right? Yes. Here if you start from this side, it is the right method, and here one of the wrong method is given because substituent group is present in this carbon atom, but here we start the numbering from this side. Therefore this is the wrong method. According to the rule, if the organic compound contain one substituent group, then you can start the numbering from that side only. Next, lowest set of locant rule or lowest sum rule. Students, remember, if the organic compound contain more than one substituent group, then the sum of the locant should be minimum. What is locant? Remember, it is the number of carbon atom which have substituent group. Next, another one rule. First, you observe this example. What if the same functional group exists twice in the chain? Yes, when you observe this compound structure, here this one contain OH group on first carbon atom as well as OH group on second carbon atoms. At the time you use the words di, tri, etc. Means similar groups are present in a same compound, then use the word di, tri, etc. See here, irrespective of the end you start from, you get the same position number of both ways. Please be careful not to number the oxygen in the functional group. You only have to number the carbon atoms in the chain. Hence the compound is butane 1,4-diol. Why but is taken here? Because it contains 4 carbon atoms. 1, 2, 3, 4. ಇಲ್ಲಿ ನಾವು ನೋಡಿದಾಗ ನಮಗೆ 4 ಕಾರ್ಬನ್ ಆಟಮ್ ಕಂಡು ಬರಕತ್ತಾವ. ಆದರೆ ಫಸ್ಟ್ನೇ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೂ OH ಗ್ರೂಪ್ ಅದ, 4ನೇ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೂ OH ಗ್ರೂಪ್ ಅದ. ಇಂಥ ಸಂದರ್ಭದಲ್ಲಿ 2 OH ಗ್ರೂಪ್ ಇರೋದ್ರಿಂದ, OH ಅಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತದ, ಇಟ್ ಈಸ್ ದ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಆಫ್ ಆಲ್ಕೋಹಾಲ್. ಹೌದಾ? ಹಾಗಾದ್ರೆ ಇದ್ರ ಹೆಸರು ಬ್ಯೂಟೇನ್ ಅಂತ ಬರ್ಕೊಂಡೆ, ಯಾಕಂದ್ರೆ 4 ಕಾರ್ಬನ್ ಆಟಮ್ ಇದ್ದು. ನೆಕ್ಸ್ಟ್ ಒಂದನೇದಕ್ಕೆ ಮತ್ತು ನಾಲ್ಕನೇದಕ್ಕೆ ಏನದ, 1ನೇ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಮತ್ತು 4ನೇ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ OH ಗ್ರೂಪ್ ಅದ. ಎಷ್ಟು ಅದಾವು? 2 ಇರೋದ್ರಿಂದ 1,4-diol ಅಂತ ಹೆಸರನ್ನ ಬರದೆ. ನೆಕ್ಸ್ಟ್, another very important, this is very important, please observe carefully. Rules for naming the compounds having more than one functional group or substituent or multiple bond. Students, remember, if the organic compound contain only one functional group, then you can start the numbering from that side. It is very easy to write the name. But if the organic compound contain more than one functional group, then you arrange them according to the priority. Students, remember the table which is helpful for writing the IUPAC name of particular compound which contain more than one functional group. See here, I already given that priority of the compounds. Carboxylic acids first, means carboxylic acids have greater priority than sulfonic acids. then anhydrides, esters, acid chlorides, acid amides, nitriles, aldehydes, ketones, alcohols, amines, alkenes and alkynes. This priority is given here. See carefully. It is the chart of priority of the groups. COH groups have higher priority than sulfonic acids. Similarly, aldehydes, ketones, alcohols, amines in the order. Okay, students, now another very important concept, that is nomenclature of bicyclic compounds. Nomenclature of bicyclic compounds. ನೆನ್ಪಿಡಿ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಈ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಎಸ್ಪೆಷಲಿ JEE ಎಕ್ಸಾಮ್, ನೀಟ್ ಎಕ್ಸಾಮ್ದೊಳಗೆ ಕ್ವಶನ್ ಕಂಪಲ್ಸರಿ ಇದೇ ಟಾಪಿಕ್ ಮೇಲೆ ಇರ್ತದೆ. ಬೈಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ಸ್ದು ಹೆಸರು ಬರೆಯೋಕೆ ಕೇಳ್ತಾರೆ. ಅವರೇ ಆನ್ಸರ್ ಕೊಟ್ಟಿರ್ತಾರೆ, 4 ಕರೆಕ್ಟ್ ಆಗಿರೋದನ್ನ ನೀವು ಐಡೆಂಟಿಫೈ ಮಾಡಿ ಟಿಕ್ ಮಾಡೋದಿರ್ತದೆ. ಎಸ್, ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ bicyclic compounds nomenclature, the two molecules are not identical, therefore they cannot have same name. Yes, how we write and what are the main observations involved in the nomenclature of bicyclic compounds? See here. If you take this example, this is one of the bicyclic compound. While writing the name of bicyclic compounds, first we observe the bridgehead carbon atoms. Remember students, this carbon atom and this carbon atom. Remember, this carbon atom and this carbon atom are the bridgehead carbon atoms. What are these bridgehead carbon atoms? Remember, these carbon atoms hold all the cyclic structures. ಈ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ನೋಡಿದಾಗ ಈ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಮತ್ತು ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಏನಾಗಿದೆ, ಇವಕ್ಕೆ ನಾವು ಬ್ರಿಡ್ಜ್ ಹೆಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಯಾಕಂದ್ರೆ ಇವು ಎರಡು ಕಾರ್ಬನ್ ಆಟಮು ಎಲ್ಲಾ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಂದ್ರೆ ಸೈಕ್ಲಿಕ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅನ್ನ ಅದು ಬೈಂಡ್ ಮಾಡ್ಯದ. ಈ ಒಂದು ಇದೇನ್ ಮಾಡ್ಯದ, ಎಲ್ಲವನ್ನ ಒಳಗೊಂಡದ, ಅಂದ್ರೆ ಬೈಂಡ್ ಮಾಡ್ಯದ. ಎಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್, while writing the bicyclic compounds, some rules are observed here. What are those? In that first one is, you can give the least number to the bridge head carbon atom. ಈ ಒಂದು ಬೈಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ ಹೆಸರು ಬರಿಬೇಕಾದ್ರೆ ನಾವು ಮೊದಲು ಯಾವ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಂದ ನಂಬರ್ ಕೊಡಬೇಕು? ಬ್ರಿಡ್ಜ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂದ್ರೆ ಯಾವ ಕಾರ್ಬನ್ ಆಟಮ್ ಎಲ್ಲಾ ರಿಂಗ್ಸ್ ಅನ್ನ ಹೋಲ್ಡ್ ಮಾಡಿದ ಹಿಡ್ಕೊಂಡದ ನೋಡ್ರಿ, ಅಂತದ್ರಿಂದನೇ ನಂಬರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳ್ತದೆ. Yes, now you can start the numbering from this carbon atom as well as this carbon atom. ಎರಡರೊಳಗೆ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಇಂದ ಸೆಲೆಕ್ಟ್ ಮಾಡಬಹುದು. ಇದು ಒಂದೇ ರೂಲ್. ನೆಕ್ಸ್ಟ್ another rule means second rule, while writing the name of bicyclic compounds, first you select the longest chain, then smallest chain. ಅಂದ್ರೆ ಎರಡನೇ ರೂಲ್ ಹೇಳ್ತದ, ಏನ್ ನೀವು ಬ್ರಿಡ್ಜ್ ಆಟಮ್ ಅಂದ್ರೆ ಕಾರ್ಬನ್ ಆಟಮ್ ಸ್ಟಾರ್ಟಿಂಗ್ ನಂಬರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿರಲ್ಲ, ಆಮೇಲೆ ಯಾವ ಸೈಡ್ ದೊಡ್ಡ ರಿಂಗ್ ಕಂಡು ಬರ್ತದ, ದೊಡ್ಡ ರಿಂಗ್ ಅಂದ್ರೆ ಹೆಚ್ಚು ಕಾರ್ಬನ್ ಆಟಮ್ಗಳನ್ನ ಒಳಗೊಂಡಿರ್ತಕ್ಕಂಥ ರಿಂಗ್ ಕಂಡು ಬರ್ತದಲ್ಲ, ಅದನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು, ಆ ಕಡೆ ನಂಬರ್ ಕೊಟ್ಕೋತ ಹೋಗ್ಬೇಕು. ಆಮೇಲೆ ಯಾವ್ದು ಸಣ್ಣ ರಿಂಗ್ ಅದಲ್ಲ ಅದನ್ನ ಕೊಡಬೇಕು ಅಂತ ಹೇಳ್ತದ. ಎಸ್, ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ರಿಮೆಂಬರ್ ದೀಸ್ ಪಾಯಿಂಟ್ಸ್ and see this example, how they write the name of this compound. You know this this one carbon atom and this one carbon atoms are the bridge head carbon atoms, and common word in presence of bicyclic compounds, the word bicyclo is used. See here, first they write bicyclo here, and what are these 311? See carefully here, if you start the numbering from this carbon atom, you know already these are the bridge head carbon atoms. If you start the numbering from this one, here 1 2 3, is it right? Yes, if you start from this 1 2 3, yes. Okay students, see here, this one is the first bridge carbon atom. Here I will give the number 1 2 3 4 5 6 and 7. Total number of carbon atoms here 7. Is it right? Yes. See here, ಈ ಒಂದು ಹೆಸರು ಬರೆಯುವಂಥ ಸಂದರ್ಭದೊಳಗೆ ಕಾಮನ್ ಆಗಿ ವರ್ಡ್ ಏನು ಯೂಸ್ ಮಾಡ್ತಾರ ಅಂತ ಹೇಳಿದೆ ನಾನು, ಬೈಸೈಕ್ಲೋ ಅಂತಕ್ಕಂಥದ್ದು. ಓಕೆ, ನಾವು ಮೊದಲು ಕಾಮನ್ ಆಗಿ ಬೈಸೈಕ್ಲೋ, ಬೈ ಅಂದ್ರೆ 2 ಸೈಕ್ಲಿಕ್ ರಿಂಗ್ ಇರ್ತಕ್ಕಂಥದ್ದು ಅಂತ ಹೇಳಿ ಅರ್ಥ, ಹೌದಾ? ಎಸ್, ರಿಮೆಂಬರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಬೈಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ಸ್ 3 rings are formed. In presence of tricyclic 4 rings are observed. Yes, here bicyclo means 3 rings. What are those? See here. This one, this V shape, this one is 1 ring, and this one is the another ring, and this one is the third ring. Means bicyclic compounds contain 3 cyclic rings. Yes, here bicyclo is the common name, and you can start the numbering from this side. No, yes, 1. And which one is the longest chain here? Apart from these 2 bridge atoms, this side means this side it contains 1, 2, 3 carbon atoms, and here only 1 carbon atom, and here 1 carbon atom. According to the rule, first you select the longest chain. Is it right? Yes. Therefore, bicyclo, what this 3 indicates? In the longest chain it contains 3 carbon atoms. Here 1, 2, 3. Yes. And next another one. If you go to this cyclic ring, it also contain 1 carbon atom. Therefore I write 1 here, and here also 1 carbon atom, and total number of carbon atoms here 7. Is it right? Therefore heft and single bond means heptane is present. And come to this example, bicyclo. Students, remember, in presence of bicyclic compounds there are 3 cyclic structures. Yes, see here. Here this V shaped is 1 cyclic ring, and here another cyclic ring, and here another cyclic ring. ಈ ಒಂದು ಕಂಪೌಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಏನು ನೋಡಕತ್ತಿದ್ದೀರಿ, ಇದ್ರ ಹೆಸರನ್ನ ಹೇಗೆ ಬರಿಬೇಕು ನಾನೀಗ? ನಿಮ್ಗೆ ಗೊತ್ತದ, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಮತ್ತು ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಎಲ್ಲ ಸೈಕ್ಲಿಕ್ ರಿಂಗ್ಸ್ ಅನ್ನ ಏನು ಮಾಡ್ಯದ, ಹೋಲ್ಡ್ ಮಾಡ್ಯದ. ಅದಕ್ಕಾಗಿ ನಾ ಇವ್ಕೆ ಎಂಥ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಅಂತ ಕರಿತೇನೆ? ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಮತ್ತು ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಬ್ರಿಡ್ಜ್ ಹೆಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಅಂತ ಕರೆದೆ. ಈಗ ಈ ಕಡೆ ಸ್ಟ್ರಕ್ಚರ್ದೊಳಗೆ ಏನದ, 1, 2 ಅಂದ್ರೆ 2 ಕಾರ್ಬನ್ ಆಟಮ್ ಕಂಡು ಬರತ್ತವ. ಇಲ್ಲಿ ಕೂಡ 2 ಕಂಡು ಬರತ್ತದ. ಇಲ್ಲಿ ಈ ರಿಂಗ್ ಒಳಗೆ 1 ಅದ, ಹೌದಾ? ಎಸ್, ದೇರ್ಫೋರ್ ದ ನೇಮ್ ಆಫ್ ದ ಕಂಪೌಂಡ್ ಈಸ್ bicyclo. bicyclo 2 ಯಾಕೆ ಅಂತ ಹೇಳ್ತೀರಾ? ಯಾಕಂದ್ರೆ ಈ ರಿಂಗ್ ಅಲ್ಲಿ ಕೂಡ ಏನದಾವ, 1, 2 2 ಕಾರ್ಬನ್ ಆಟಮ್ ಕಂಡು ಬರತ್ತವ. ಈ ರಿಂಗ್ ಅಲ್ಲಿ 1, 2 2 ಕಂಡು ಬರತ್ತವ. ಅಂದ್ರೆ ಈಗ ಲೋವೆಸ್ಟ್ ಇರೋದು ಯಾವುದು? ಇದು 1. ಅದಕ್ಕೆ ನಾನು 2, 2, 1 ಅಂತ ಬರೆದಿದ್ದೇನೆ. ರಿಮೆಂಬರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಬೈಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಫಸ್ಟ್ ವಿ ರೈಟ್ ದ ನಂಬರ್ ವಿತ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್, ದೆನ್ ಲೋವರ್ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್. ಈ ಒಂದು ಆರ್ಡರ್ನ ಯಾವ ಆಧಾರದ ಮೇಲೆ ಬರೀಬೇಕು ಅಂದ್ರೆ, ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಿಂದ ಕಡಿಮೆ ಸಂಖ್ಯೆ ಅಂದ್ರೆ ಇಳಿಕೆ ಕ್ರಮದಲ್ಲಿ ಬರಿತಾ ಹೋಗಬೇಕು. ಅದು ಎಲ್ಲಿ? ಬ್ರಾಕೆಟ್ ಒಳಗೆ. ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಹಿಯರ್ 7 means heptane is the word. Okay students, this is about nomenclature of bicyclic compounds. ಈಗ ನಾವು ಬೈಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಹೆಸರನ್ನ ಬರೆಯೋದು ತಿಳ್ಕೊಂಡ್ವಿ. ಅವಾಗ ನಾವು ಏನು ಮಾಡಿದ್ವಿ? ಬೈಸೈಕ್ಲೋ ಅನ್ನೋದನ್ನ ವರ್ಡ್ ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಫಸ್ಟು ಲಾಂಗೆಸ್ಟ್ ಚೈನ್, ಆಮೇಲೆ ಲೋವೆಸ್ಟ್ ಚೈನ್, ಅದ್ರ ಪ್ರಕಾರ ನಂಬರ್ ಕೊಡ್ತಾ ಹೋಗಿದ್ವಿ. ಆದರೆ ಇದೇ ಥರ ಸ್ಪೈರೋ ಕಂಪೌಂಡ್ಸ್ ಅಂತ ಕೂಡ ಕಂಡು ಬರ್ತಾವ. ಸ್ಪೈರೋ ಕಂಪೌಂಡ್ಸ್ ಅಂದರೆ ಅಲ್ಲಿ 2 ರಿಂಗ್ಗಳು ಏನಾಗಿರ್ತಾವ, ರಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಒಂದೇ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ದಲ್ಲಿ ಜಾಯಿಂಟ್ ಆಗಿರ್ತಾವ. ಅಂಥ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಕೂಡ ನಾವು ಹೆಸರು ಬರೀಬೋದು. ಡ್ಯೂರಿಂಗ್ ದ ಟೈಮ್ ವಿ ಯೂಸ್ ದ ಕಾಮನ್ ವರ್ಡ್ ಸ್ಪೈರೋ. ಇಲ್ಲಿ ಬೈಸೈಕ್ಲೋ ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ರಿ, ಅಲ್ಲಿ ಸ್ಪೈರೋ ಅಂತ ವರ್ಡ್ ಯೂಸ್ ಮಾಡ್ತೇವೆ. ಸ್ಪೈರೋ ಅಂತ ಬರೋದು. ನೆಕ್ಸ್ಟ್ ಬ್ರಾಕೆಟಲ್ಲಿ ಏನು ಮಾಡಿದ್ರಿ ನೀವು? ಬೈಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ಸ್ದೊಳಗೆ ಮೊದಲು ಲಾಂಗೆಸ್ಟ್ ಚೈನ್, ಆಮೇಲೆ ಶಾರ್ಟ್ ಚೈನ್ ಅನ್ನ ನಂಬರ್ ಕೊಟ್ಟಿದ್ರಿ. ಅಂದರೆ ಅಲ್ಲಿ ಎಷ್ಟು ಕಾರ್ಬನ್ ಆಟಮ್ ರಿಮೈನಿಂಗ್ ಅದಾವ ಅನ್ನೋದನ್ನ ತೋರಿಸಿದ್ರಿ. ಆದರೆ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಸ್ಪೈರೋ ಕಂಪೌಂಡ್ಸ್ ಫಸ್ಟ್ ಯು ಸೆಲೆಕ್ಟ್ ದ ಲೋವೆಸ್ಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಕಂಟೈನಿಂಗ್ ಚೈನ್. ಅಂದರೆ ಸ್ಪೈರೋ ಕಂಪೌಂಡ್ಸ್ದು ನಂಬರ್ ಏನು ಕೊಡ್ತಿರ್ತೀರಲ್ಲ, ಅವಾಗ ಕಡಿಮೆ ಸಂಖ್ಯೆ ಕಾರ್ಬನ್ ಆಟಮ್ ಇದ್ದದನ್ನು ಫಸ್ಟ್ ಬರ್ಕೊಂಡು ಆಮೇಲೆ ದೊಡ್ಡ ರಿಂಗ್ ಅಂದರೆ ಹೆಚ್ಚು ಕಾರ್ಬನ್ ಆಟಮ್ಗಳ ಒಳಗೊಂಡಿರೋದನ್ನು ಕೊಡಬೇಕು. ಉಳಿದಿದ್ದೆಲ್ಲ ಸೇಮ್ ಪಾಯಿಂಟ್. ಎಸ್, next another very important concept, that is about isomerism. Student, first question is, what is isomerism and how it classified? Students, the compounds having same molecular formula but have different physical and chemical properties are called isomers, and the process is known as isomerism. This is one of the easiest definition, and also we can define this: the organic compounds having same molecular formula but different structures are known as isomers. The phenomenon is known as isomerism. And how isomerism is classified? Students, usually isomers are observed in presence of structural isomerism and stereoisomerism. There are different type of structural isomerism. One is chain isomerism, position isomerism, functional isomerism, ring or ring chain isomerism, metamerism, as well as tautomerism. Mainly, you remember the concept of chain isomerism, position, functional, meta, and tautomerism. In presence of stereoisomerism, there are two types. One is geometrical isomerism and another one optical isomerism. Yes, students, in presence of structural isomerism, we know main important points: chain isomerism, position isomerism, functional, meta, and tautomerism. First, come to the point of chain isomerism. What is chain isomerism? Here, the compounds having same molecular formula but change in the chain of carbon atom. ಇಲ್ಲಿ ಒಂದು ಕಂಪೌಂಡ್ಸ್ ನಮ್ಮ ಅನುಸೂತ್ರವನ್ನು ನೋಡಿದಾಗ ಅದು ಸೇಮ್ ಆಗಿ ಕಂಡು ಬರ್ತಿರ್ತದೆ, ಆದರೆ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಚೈನ್ ಏನು ಮಾಡಿರ್ತದೆ, ಡಿಫ್ರೆಂಟ್ ಆಗಿ ಕಂಡು ಬರ್ತಾ ಇರ್ತದೆ. The compounds having same molecular formula but change in the chain of carbon atom is known as chain isomerism. If you take an example, N-butane means normal butane and isobutane. Normal butane and isobutane are the best examples for chain isomerism. Here, this one is the normal butane structure. Here, this one is the 2-methyl propane. Both have same molecular formula. What number of carbon atoms it contains? This also contains same number of carbon atom. Number of hydrogen atoms here present in presence of butane is same as in the methyl propane, 2-methyl propane. When you observe these two structures, only change in the chain of carbon atom. Therefore, these are the examples for chain isomerism. Next, positional isomerism. Students, remember, in presence of position isomerism, the compounds having same molecular formula but change in the position of the functional group. Yes, remember students, in presence of position isomerism, the functional group position is only changed but not entire functional group. ಈ ಒಂದು ಪೊಸಿಷನ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ನೋಡಿದಾಗ ನಮಗೆ ಎರಡು ಐಸೋಮರ್ಸ್ ಅಂದರೆ ಸಮಾಂಗಿಗಳು ಅಂತ ಏನು ಹೇಳ್ತೇವಲ್ಲ, ಅವನ್ನ ನೋಡುವ ಸಂದರ್ಭದಲ್ಲಿ ಅವು ಅಲ್ಲಿ ಏನು ಕಂಡು ಬರ್ತಾ ಇರ್ತದಂತ, ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಇರುವಂಥ ಸ್ಥಾನ ಬದಲಾವಣೆ ಆಗಿರ್ತದೆ. ಬಟ್ ದ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಆಫ್ ದ ಕಂಪೌಂಡ್ ಈಸ್ ಸೇಮ್. Students, what is positional isomerism? The compounds having same molecular formula but change in the position of the functional group. But here functional group is same. See here, but1-ene and but2-ene are best examples for position isomerism. When you observe this structure, here double bond is present on first carbon atom. When you observe this compound, here double bond is present on second carbon atom, but number of carbon atoms here as well as here is 4, and number of hydrogen atoms here 1, 2, 3, 4, 5, 6, 7, 8. Is it right? Here also the number of hydrogen atoms are 8. Next, functional isomerism. Students, remember, the compounds having same molecular formula but change in the functional group is known as functional isomerism. The compounds having same molecular formula but change in the functional group is known as functional isomerism. ಈ ಒಂದು ಫಂಕ್ಷನಲ್ ಐಸೋಮೆರಿಸಮ್ ಅನ್ನ ನಾವು ತೋರಿಸ್ಬೇಕು ಅಂದ್ರೆ ಆ ಒಂದು ಐಸೋಮರ್ಸ್ ಅಲ್ಲಿ ಏನಿರ್ತದಂತ, ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇರ್ತದಂತ, ಆದರೆ ಎಂಟೈರ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅಂದರೆ ಕ್ರಿಯಾ ಗುಂಪು ಬೇರೆ ಬೇರೆ ಕಂಡು ಬರ್ತಾ ಇರ್ತದಂತ. Yes, when you observe these structures or isomers given here, It is one of the propanoic acid, means it contains COOH group, and here it is one of the ether. Yes, benzoate, it is one of the ester. RCOOR group is present here. It is one of the ester, but molecular formula of these compounds is same. Next, metamerism. What is metamerism? Students, when you observe the compounds or isomers, they having same molecular formula but change in the alkyl groups present on either side of the functional group. Yes, what are metamers? The compounds having same molecular formula but change in the alkyl groups present on either side of the functional group. Best example, pentan 3-one, pentan 2-one are simple examples. But here I give another examples. It is one of the diethyl ether, and here methyl propyl ether. Yes, these are two ethers. But when you observe the alkyl groups which are present on either side of the functional group, they are different here, because here CH2 CH3 is present, but here only CH3 group is present here. In this side CH2 CH3 is present, here CH2 CH2 CH3 is present, but molecular formula of both the compounds is same. These are examples for metamerism. Next, ring chain isomerism. Here the compounds having same molecular formula represents two or more compounds. It differs in the mode of linkage of carbon atoms. The isomers have either open chain or closed chain compounds. Yes, it indicates the ring chain isomerism. Here the compounds structures are represented in open chain or closed chain. Here it is in open chain structure. This is the structure of propane, and this one is the cyclic ring structure. This is one of the cyclopropane. It is observed in presence of cyclic ring. It is present in open chain ring, but they have same molecular formula. Yes, another very important concept, that is tautomerism. This method is also called as keto-enol conversion, because this method also gives the isomers of organic compound by converting with each other. Students, observe some points related to tautomerism. The same molecular formula represent two or more compounds. It exists in dynamic equilibrium with each other. It can be present in many forms such as nitro form and acid form, keto form as well as enolic form. Yes, if you take an example ethanol, then it is converted to ethanol, means aldehyde group is changes to alcohol group. Next, stereoisomerism, another point. First, go to the definition point. What are stereoisomerism or what are stereoisomers? The compounds having same molecular formula and same structural formula but differ in the special arrangement of atoms in the structure is known as stereoisomerism. Here we observe the special arrangement of atoms. In presence of stereoisomerism, there are two types. One is geometrical isomerism and another one optical isomerism. Now, the point related to geometrical isomerism. What is geometrical isomerism? The compounds having same molecular formula and same structural formula, but change in the arrangement of atoms around the double bond. We know, students, in presence of geometrical isomerism, there is a special arrangement of atoms around the double bond. In presence of stereoisomerism, there is a special arrangement of atoms is present. Is it right? Yes. But especially in presence of geometrical isomerism, the special arrangement of atoms are observed around the double bond. Yes, if you consider these two examples, here two carbon atoms which containing double bond and two similar groups are present on same side of the double bond. ಈ ಒಂದು ಎರಡು ಎಕ್ಸಾಂಪಲ್ಸ್ ಏನು ನೋಡ್ತಾ ಇದ್ರಿ ಸ್ಟ್ರಕ್ಚರ್ಸು, ಇದರಲ್ಲಿ ನೋಡ್ರಿ ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಯಾವ ಬಂಧವನ್ನು ಒಳಗೊಂಡದ, ದ್ವಿಬಂಧವನ್ನ ಒಳಗೊಂಡದ. ಅದೇ ಕಾರ್ಬನ್ ಸೇಮ್ ಸೈಡ್ ಏನಾಗ್ಯಾವ, ಇಲ್ಲಿ ಒಂದು CH3 ಅದ, ಇಲ್ಲಿ ಒಂದು CH3 ಅದ. ಈ ಡಬಲ್ ಬಾಂಡ್ ಸೇಮ್ ಸೈಡ್ ಏನೈತಂತ CH3 ಅರೇಂಜ್ಮೆಂಟ್ ಕಂಡು ಬರಾಕತ್ತೈತಿ. Remember students, if two similar groups present on same side of the double bond, then it is in cis form. ಈ ತರ ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಮಧ್ಯೆ ಏನು ಡಬಲ್ ಬಾಂಡ್ ಐತಲ್ಲ, ಅದ್ರದ್ದು ಒಂದೇ ಸೈಡ್ ಎರಡು ಸಿಮಿಲರ್ ಅಲ್ಕೈಲ್ ಗ್ರೂಪ್ಸ್ ಕಂಡು ಬರಾಕತ್ತಿದ್ದು ಅಂದ್ರೆ ಅದ ಸಿಸ್ ಫಾರ್ಮ್. ಅಬ್ಸರ್ವ್ ದಿಸ್ ಸ್ಟ್ರಕ್ಚರ್. ಹಿಯರ್ ಬಿಟ್ವೀನ್ the carbon atoms there is a double bond, and here CH3 group is present in one side and another CH3 group is present in opposite side. Remember students, if two similar groups or alkyl group present on opposite side, means it is present in 180 degree, then this is trans form. Remember students, cis and trans form is observed in presence of geometrical isomerism. Next, optical isomerism. What is optical isomerism? The compounds having same molecular formula and same structural formula but differ in the placement of atoms due to the plane polarized light. It is one of the easiest definition for you. What is optical isomerism? The compounds having same molecular formula and same structural formula but differ in the placement of atoms due to the plane polarized light. ಈಗ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಅಲನೈನ್ ಸ್ಟ್ರಕ್ಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, ಹೌದಾ? ಈ ಒಂದು ಅಲನೈನ್ ಸ್ಟ್ರಕ್ಚರ್ ಮುಂದೆ ಸಪೋಸ್ ನಾನು ಮಿರರ್ ಇಟ್ರೆ ಅದು ಯಾವ ತರ ಕಾಣ್ತದ ಅನ್ನೋದನ್ನ ಇಲ್ಲಿ ತೋರಿಸಿದ್ದಾರೆ. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ COH ಗ್ರೂಪ್ ಅದ, ಇಲ್ಲಿ COH ಗ್ರೂಪ್ ಅದ, ಇಲ್ಲೊಂದು CH3 ಗ್ರೂಪ್ ಅದ, ಅದು ಇಲ್ಲಿ ಮಿರರ್ ಇಟ್ಟಾಗ ಇಲ್ಲಿ ಕಂಡು ಬರಾಗ್ತದ. ಈಗ NH2 ಈ ಕಡೆನೆ ಕಂಡು ಬರಾಕತ್ತದ. ಈ H ಹೈಡ್ರೋಜನ್ ಈ ಕಡೆ ಇಲ್ಲಿ ದೂರ ಅದ ಅಂದ್ರೆ ಈ ಕಡೆ ಇಲ್ಲಿ ದೂರ ಕಂಡು ಬರ್ತಾ ಇದೆ. Yes. What is the difference between these two? The placement of atoms is different. Is it right? Yes. This is about optical isomerism. Next, another very important concept, students, that is about electronic effects, or also called as electron displacement effects. Students, one thing you remember, due to different electronegativity of combining atom, a pair of electrons displaced completely or partially is known by different effects called electronic effects. In presence of electronic effects, inductive effect, mesomeric effect, electromeric effect and hyperconjugation effect, these are the main effects and very important for your CET examination. While studying about the electron displacement effect, you remember the permanent polarity or permanent polarization and temporary polarization. Permanent polarization occurs in ground state under the influence of an atom or substituent group. Remember, inductive effect, mesomeric effect and hyperconjugation effect are the permanent effects, and temporary polarization occurs in presence of attacking reagent. Remember students, electromeric effect is one of the temporary effect because it happens only in presence of attacking reagent. First come to the point of inductive effect. What is inductive effect? We know definition. The permanent polarity produced in a molecule due to the displacement of pair of electrons. Displacement of pair of electrons towards more electronegative atom is known as inductive effect. Students, remember, it is one of the permanent effect. It is produced in a molecule due to the displacement of electrons. Usually inductive effect, the sigma electrons are involved here. These electrons are migrate towards the more electronegative atom is known as inductive effect. If you take an example, methyl chloride or ethyl chloride, then it shows inductive effect. In presence of methyl chloride, chlorine is more electronegative, hence the bond pair of electrons move towards chlorine atom. Is it right? If you consider this example, here this CH2, here CH3, another group, is it right? Yes, here Cl. It is one of the more electronegative atom, therefore it accepts the electron. If it gets the electron, then it gets partial negative charge, and the carbon atom which gives the electrons, it gets positive charge. Is it right? Another important point, if the distance from the more electronegative atom increases, then inductive effect decreases, remember. Then polarization of sigma bonds results a partial charge over adjacent atoms and transmitted along a chain. And another point occurs in sigma bonds only. This inductive effect is observed in presence of sigma bonds. Sigma electrons are involved, means sigma bonds are present here. CH bond is used to standard zero effect is assumed in this case. In presence of inductive effect, there are two types. One is positive inductive effect and another one negative inductive effect. What is negative inductive effect? Remember students, the substituent group shows negative inductive effect when the displacement of electron takes place towards it. When you observe this example here carbon atom is present. Here carbon atom is present, and here one of the more electronegative atom. Here this group shows negative inductive effect when the displacement of electron takes place towards it. ಈ ಒಂದು ಕ್ಲೋರಿನ್ ಅಟಮ್ ತನ್ನ ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ತಗೊಳ್ತಕ್ಕಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಇದು ನೆಗೆಟಿವ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ತೋರಿಸ್ತದಂತ. ಇಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಈ ಕಾರ್ಬನ್ ಅಟಮ್ ಗಿಂತ ಈ Cl ಅಟಮ್ ಏನಾಗಿರ್ತದೆ, ಇದೀಗ ಮೋರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಆಗಿರ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಪಾಸಿಟಿವ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್. What is positive inductive effect? The substituent group shows positive inductive effect when the displacement of electron takes place away from it. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಈಗ ಏನ್ ಕಂಡು ಬರತ್ತದಂತ, ಪಾಸಿಟಿವ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ಎಲ್ಲಿ ಕಂಡು ಬರಕತ್ತದ ಅಂತಂದ್ರೆ, ಯಾವಾಗ ಕಂಡು ಬರ್ತದ ಅಂದ್ರೆ, ಈ ಒಂದು ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಇರ್ತದಲ್ಲ, ಅದು ಅಲ್ಲಿ ತನ್ನ ಕಡೆಯಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಇನ್ನೊಂದಕ್ಕೆ ಬಿಟ್ಕೊಟ್ಟಿರ್ಬೇಕು. ಡ್ಯೂರಿಂಗ್ ದಿಸ್ ಟೈಮ್ the carbon is more electronegative than the substituent group. Is it right? Yes. Now some applications of this inductive effect. Students, remember this inductive effect, it explains the relative stability of carbocations. Means stability increases with increase in the number of alkyl groups. I think you know about primary carbocations, secondary as well as tertiary carbocations. In that, this inductive effect, it explains the stability of carbocations in the order primary is less than secondary less than tertiary carbon atoms. And it also explains the relative stability of carbon ions. Carbon ions in the order of means decrease in the order of tertiary is less than secondary is less than primary. And I'll come to the point of acidic strength. This inductive effect, it explains the electron withdrawing group decreases the negative charge on the carboxylate ion by stabilizing it, hence acidic strength increases. As remember this point, electron withdrawing group decreases the negative charge on the carboxylate ion by stabilizing it, hence the acid strength increases. It is observed in the pattern. Next, another point, mesomeric effect. What is mesomeric effect? This effect is also called as resonance effect. The permanent polarity produced in a molecule due to the interaction between two pi bonds or pi bond and lone pair of electrons is called mesomeric effect. This definition shows which type of electrons involved in resonance effect. Students, remember, either two pi bond electrons or pi and lone pair of electrons are involved in the mesomeric effect. Yes. See this structure, this is structure of benzene, and these two structures are the hybrid structures, canonical structures are also called as resonance structures of benzene. What is the difference observed in these two structures? There is a displacement of pi bonds. Students, in presence of mesomeric effect, there are two types. One is negative mesomeric effect and another one positive mesomeric effect. Come to the point of positive mesomeric effect. The substituent group which shows the positive mesomeric effect when the displacement of electron takes place away from it. Yes, what is positive mesomeric effect? The substituent group or attached group which shows positive mesomeric effect when the displacement of electron takes place away from it. Yes, when you observe the structure, it contains OH group on the oxygen atom. There are one pair of electrons, therefore they migrate towards the ring. Is it right? Therefore the electrons takes place away from the group. Therefore, when you observe these structures, here bond means this double bond moment means the 5 electrons are moved here, and here lone pair of electrons means in the positive mesomeric effect the lone pair of electrons and pi electrons are involved here. Next, another point, negative mesomeric effect. The substituent group which shows negative mesomeric effect when the displacement of electron takes place towards it. Is it right? Towards it means when you observe this structure, see here, when you observe this structure, here pi electrons are moved towards the substituent group. Here NO2 group is present and pi electrons move towards the substituent group. During this time, the negative mesomeric effect is observed. And these are the resonance structures of nitropentane. Some points is very important in presence of resonance or mesomeric effect. Remember students, only 5 electrons or non-bonding electrons are involved here. Energy of resonance hybrid should be lower than contributing structures. Structures should be planar. Number of paired or unpaired electrons should be same. Contributing structures have nearly same energy. Means the structures which individually do not represent the original structures is called resonance structures or hypothetical or canonical structures. Remember students, the energy of all the resonance structures is same. Next, stability of resonating structures. More the number of covalent bonds, more stable is the structure. Structure with complete octet are more stable. Negative charge should be on more electronegative atom. Like charges should not be adjacent positions. These are some points you remember. Next, another type of effect, that is electromeric effect. Remember students, already we know electromeric effect, it is one of the temporary effect because it takes place only in presence of attacking reagent. Yes, come to the definition point of electromeric effect. It is a temporary effect produced in a molecule due to transfer of pi electrons of double bond to one of the bounded atom in presence of attacking reagent is called electromeric effect. It is one of the temporary effect. Why you know? Because it takes place in presence of attacking reagent. If you remove that attacking reagent, it comes to the original state. Here also there are two types. One is positive electromeric effect and another one negative electromeric effect. First point, positive electromeric effect. The attacking reagent shows positive electromeric effect when the displacement of electron takes place towards it. Yes, see here this example, here ethene CH2 CH2. Here if you take attacking reagent H plus, it attacks. Here pi electrons are involved, means this carbon atom accept the electron, means this one gets negative charge. Therefore here if you add electrophile, then it migrate towards the negative charge. Is it right? Yes. Therefore the structure is observed like. Remember students, this migration of electron takes place in presence of only attacking reagent. If you remove this H plus, then it comes to the original state. Because of this point, it is one of the temporary effect. Next, another one, negative electromeric effect. Here the attacking reagent shows negative electromeric effect when the displacement of electron takes place away from it. Here I take Cn minus is one of the attacking reagent to one of the group. Is it right? Here double bond means pi electrons are migrated, and here already we add Cn minus. It contains negative charge and it attacked to the positive side carbon atom. Yes, this is about electromeric effect. Next, another one, last concept, that is hyperconjugation effect. This effect is also called as Baker-Nathan effect. Students, remember, it is one of the permanent effect produced in a molecule due to the interaction between the sigma and pi electrons of adjacent bond. Yes, if you take this example, here carbon valency is 4, but I write 1 plus means it already donate 1 hydrogen. Yes, in this structure it is given as H plus, means here bond is removed. Only bond is removed. Because of this point, this hyperconjugation effect is also called as no bond resonance. Students, remember, in alkenes there is one less real bond in the canonical structures than hyperconjugative structures. Yes, the stability of free radicals. Methyl free radical is less than primary, less than secondary, less than tertiary. Okay, students, next come to the point of hybridization concept. What is hybridization? The mixing of atomic orbitals is called hybridization. The mixing of atomic orbitals is known as hybridization. Why I discussing this concept? Because you must know or identify the carbon atom involved hybridization. Students, when you observe the organic compound structure, if it contains 4 sigma bonds, means 4 single bonds, then the carbon atom possesses sp3 hybridization. And if the organic compound contains 3 sigma bond and 1 pi bond, and the carbon atom possesses sp2 hybridization. If carbon atom containing 2 sigma and 2 pi bonds, 2 sigma and 2 electrons, 2 pi electrons, then it possesses sp hybridization. Yes, there are 3 types, mainly sp3, sp2 and sp. One of the s orbital and one p orbital combined to give sp hybridization. One of the s orbital and 2 p orbitals are combined to give sp2 hybrid orbitals. And one of the s orbital and 3 p orbitals are combined to give sp3 hybrid orbitals. Okay, students, see here sp3 hybridization. Here one of the s orbital and 3 orbitals. 3p orbitals means one is px, another one py and another one pz are combined to give 4 hybrid orbitals. Here 1, 2, 3, 4 hybrid orbitals. Hybrid orbital means they contain same energy. Yes. Next, another point, sigma and pi bonds. Number of means calculation of number of sigma and pi bonds is also important in this chapter. If single bond is present, then it count as 1 sigma bond. If one double bond is present, you count 1 sigma and 1 pi. If triple bond is present between the carbon atoms, you count 1 sigma and 2 pi bonds. Next, another point, when the sigma bond is formed due to the axial overlapping of atomic orbitals, and pi bond is formed due to the sideways overlapping of atomic orbitals. Okay, thank you, students.